Hello all you learners out there, this is Mark from Lizard Learning and I'm here to present another maths bit. Today's little topic will be equivalent fractions, and I know a little bit about equivalent fractions, and if I know more than you, then you'll learn from me. If you, however, know more than I do about equivalent fractions, please contact me and I can learn from you. Okay, we're all learners in this big wide world. Okay, let's start with the word war. Fractions. We have decimal and common fractions. Here's a decimal fraction, 0.4. Here's a common fraction expressed with a numerator, which is the 4, the top number, and a denominator, which is the 10, the bottom number. That's on a common fraction. Now the line between them is a vinculum. We call that a vinculum, and like everything else in maths, it's got little instructions that go with it, or it's got a little job to do. And what it is actually a divide sign. Okay, so what we've divided things into here is tenths. And the top number, the numerator, will tell us how many of those tenths that we take. Okay, just to repeat that, the denominator is the bottom number, and the bottom number tells us how many pieces we've chopped something up into. The top number, which is the numerator, tells us how many of those pieces we have taken. Once again, if I had 6/7, the vinculum, that part, tells us how many parts, whatever's underneath the vinculum, tells us how many parts we've broken something into, in which case this is 7. And the top part tells us how many of those parts we have taken. If I wrote a mixed number, 2 3/5, for instance, we call that a mixed number because it's made up of a whole number and a common fraction. So that there, right, little fella right there, is a whole number. In 7.6, whole numbers column, it's the ones house, whole numbers. Decimal, anything after that is a fraction, and because it's decimals, we're dividing it into tenths. Okie dokie, that should do that part. I said okie dokie. Yep, I'm a farmer's son, brought up on the farm, brought up in Kenilworth, wonderful childhood. Dad made us work very hard. Still, I ended up being a useful human being in my opinion, and thank you very much, Dad, for that. Okay, moving right along. Otherwise I'll start telling stories about my hometown and what we used to do as kids that we'd probably be put into jail for these days. Anyway, that's for another time. Maybe in some tutoring lessons later. Definition of equivalence. Okay, we've got a definition of equivalent. What does equivalent mean? Well, out of the dictionary, it's something that has the same value, use, meaning, etc. as another thing. In our case, it is something. In our case, it is something that has the same value. Equivalent fractions look different, but they have the same value. Okay, that's just to prove that I know what I'm talking about. A definition of what equivalent means. Pizza lovers. Now, everyone talks about pizzas when I talk about equivalent fractions. It's just something we go through automatically. That is one pizza. Yep, and as I said before, the vinculum looks a bit different here, but that is the vinculum. There. You might write it like that, or you might write it like that. I prefer to write it like that, but on my computer, 1 divided by 1, that is a whole number. In other words, you have divided something into one piece, and you've taken the whole piece. So I've divided this, well, here's this pizza. I've divided it into one pizza. I haven't touched it. It's still one pizza. I've divided it into one big piece. And how much have I taken? I've taken the whole lot. Whoops. taking the whole lot. Let's take the whole lot. There we go. That's my one pizza. I've joined it back together. Okay, I'll put that back up there. Now, if I might take half that pizza. Actually, I'm not going to do that at all at this stage. I'm going to take one half of the pizza. I'm going to take the other half of the pizza. How many pieces have I chopped that pizza into? I've chopped it into 2 pieces, but I've taken both the pieces. So there's a fraction to that, 2 out of 2. The rule applies, right? The bottom number, which is the 2, tells us how many pieces I divide that pizza into. The top number tells us how many it took. Well, I took them both. So really, we have still got the whole pizza. You can put them back together. We've got both halves, but they still make the whole thing. All right, now, how about if I chop this pizza into 4 bits? Chop it into 4 bits. I take all of them. Right? Chop it into 4 pieces, but I take 4 pieces. I still have the whole pizza. I'm a bit of a pig, so I take the whole pizza. So, let's get rid of that. How about now that I get rid of that's the whole pizza. Now if I chop this pizza into 1, 2, 3, 4, I'm chopping it into 8 bits, 5, 6, 7, and 8. Now if I put all those pieces back together, I would have the whole pizza still, just chopped into 8 bits. I chopped the pizza into 8 pieces. Top number, the numerator tells me I've taken all 8 of them. So I've got the whole pizza. Okay, how are we going with this? This is how we're going with this. All the pizzas have been chopped into different pieces, but all the pizzas are still the same whole pizza. As I said before, the denominator tells us how many parts we break the whole into. The top number tells how many pieces we take. So, even though I've chopped it into 2 pieces here, I've still taken 2, got the whole pizza. Even though I've chopped the next one into 4 pieces, I've taken all 4, I've got the whole pizza. Even though I've chopped the thing into 8 pieces, I've taken all 8 of them, I've still got the whole lot. So, equivalent fractions. They're all the same. They are all still the whole pizza. All they've done is just chop them into different numbers of pieces. They've still taken the whole lot. So these are all equivalent. Same amount of the pizza. And this is something very important. When I'm going to talk about this now, when we actually divide a pizza up, take the whole pizza, we divide it into 2 pieces, or we make lots of 2. Lots of 2. Then we made lots of 4, and then lots of 8. Lots of. Multiply. We've made, in the first case, twice as many pieces as originally were there. Then we made 4 times as many pieces as the original. And then we made 8 times as many as the original. So what is the operation that we are using when we are doing lots of? Well, the operation we're using will be multiply. Notice multiply. Notice we divided into 2 pieces. We multiplied. We chopped that whole pizza into 2 pieces. When we had 2 pieces, 2 times 1 is 2. 2 pieces. Now we did the same thing to the top number. 2 times 2 equals 2. 2 times 1 equals 2. So what we do to the bottom, the denominator, when we're chopping it up, we must do to the denominator. There's our rule. What you do to the denominator, you do to the numerator. Exactly the same. It's either multiply, or if you want to go back to where we started from, it's divide. Don't worry about it if you're getting a little bit confused, but just look at the pattern. All right, okay, if we divide something into 4 bits, what do we multiply by? Chopped it up into 4 bits. We took all 4 bits, so we multiplied the denominator by 4. We multiply the numerator by 4. Chop the pizza up into 8 bits. Down there we chop it up into 8 bits. Multiply it by 8. 8 bits. We do the same to the numerator. Okay. Good. There's the rule. What you do to the denominator, do to the numerator. And the operation we use is multiply to make the number of pieces bigger. To make the number of pieces smaller, we do this opposite. We divide. So if I wanted to make, this, let's go down here. I've got 8 bits of pizza. I chopped it up into 8 bits. I took all 8. Let's, divide by 8. 8 into 8 goes 1. 8 into 8 goes 1. We're right back to where we started. We got the whole pizza. Still have the whole pizza here. 8 bits out of 8. But if we divide by 8, top and bottom, we make the fraction simpler. We go back to having just the 1 pizza, and we're taking the 1 pizza. We haven't chopped it up into any bits yet. It's just sitting there. As I said, I'm a pig. I'll grab the whole thing and shove it down my mouth before anybody else can get any. Had brothers, you know. It was survival. You had to get into the food first. Okay, equivalent fractions starting with a half. Okay, we've got a half a pizza there. Let's chop that into 2 bits. Righto. Starting with a half. There's our, I'll put that over there. There's our, whoops, I'll grab that. There's our half a pizza. I chop it into 2 bits. And now I have got, just wait a second while I change something. There we go. I chop that up. Got half a pizza there. I'll just get rid of that. There's my half a pizza. Just getting organised here. All right, half a pizza. Well, if I took half a pizza, if I divide the pizza up into 4 pieces, let's call it a circle. It's a circle. It's not a pizza. Okay, I divide the whole circle up into 4 bits. I divided the whole circle up into 2 bits, but I'm only taking half. Right, I'm only taking half. I have divided this up into quarters, right? There's 4 of them. I've divided the whole circle up into quarters, but I'm only taking half. So how many quarters will that be? It will be 2 quarters. There we go. I'll get rid of that. It will be 2 quarters. Put the half back on there. Grab my quarter. Okay, take that off. I'll divide it up into quarters, and I have 2 quarters. Now, if I divide this up into, let's say, 8ths, I'm only going to take half. Remember, we started with the half. I'm only taking half of it, but I divided the whole circle up into 8 bits. There we go. I just have to change that a little. How many are there? I divided it up into 8 bits, but I only have 4 of them, 4/8. Right, let's have a look. A half. As we saw, a half is the same as 2/4, which is the same as 4/8. Once again, looking at the rule here. Okay, we got half a pizza, right? Half a pizza. We divide that half a pizza up into halves again, and we got quarters. What do we do to get quarters? We multiply it by 2. What we do is the bottom number, the denominator, we must do to the numerator. We always remember that rule. So a half is the same as 2 times 1 is 2. 2 times 2 is 4. Right? Now we took the half and we divided it up into 8s. 8 bits. We only took half the pizza. We divided that half a pizza into 4 bits. Same with the top. 4 2s are 8, 4 1s are 4. So we end up with 4/8. That's our equivalent fractions. And you can see that 4 is half of 8. So 4 is half of 8. So it's still half a pizza. It's just we divided it into 8s and we've got 4 of them. Up here, we divided the pizza into 4 pieces, but we only took half the pizza. So what's half of 4? 2, if you want to look at it that way. So 2/4 is the same as a half. 4/8 is the same as a half. If I divide the pizza up into 100 pieces, very little pizzas or a huge pizza, half would be 50. 50 out of 100. Still the same amount of pizza, still half the pizza. If we divide by the top number by 50, 50 into 50 goes 1. 50 into 100 divided by 50. How many 50s in 100? 50 and 100, the 2 of them. 2. We're back to where we started. Okay, we're getting the idea about equivalent fractions. Now let's look at equivalent fractions with other denominators. Let's start with, say, 7s. Supposing I, for some reason, had to divide something into 3/7. Well, first of all, we know that the denominator is telling us I divided something into 7s. The numerator tells us I took 3 of them. So it's a fraction. It's part of the whole number. Once again, remembering how many 7s are there in the whole number or the whole thing? 7 7s. You can show that by dividing the bottom by 7, dividing the top by 7. What do you get? 1. On the bottom, 1. You're back to your whole numbers. Once again, let's go back to 7 7s. I chopped the denominator into 7 bits. Okay, so there are 7 bits now. I must do the same to the top. 7 times 1 is 7. Remembering that if the numerator is the same as the denominator, it really equals 1. If someone asks you, oh yeah, what's 1? What's 1 as a common fraction? You could say a whole bunch of things. 1 is a common fraction. It could be 8/8, could be 10/10, right? So long as the numerator and the denominator are the same, it means you chop something up into 8 bits there. You've taken 8 of them, all of them. Chop something up into 10 bits. You take 10. You've taken the lot. You've taken the whole thing, whole number. Righto, 3 7s. By now, we should be able to say, righto, 3 7s. If I wanted to turn that into 14ths, what have I done there? I've chopped each of those 7s into 2 bits. 2 7s are 14. If I multiply by 2 there, I must multiply by 2 there. 2 3s are 6. Remember the golden rule. Whatever I multiply the denominator by, I must multiply the numerator by. Or it could be the other way around. Whatever I multiply the numerator by, I must multiply the denominator by the same thing. Okay, so 3 7s once again could be equivalent fractions. We've already done one of those. 6 14ths. What if I chopped the bits into 10 pieces? I'd end up with 70 bits. remembering I only took this many parts of the 7 parts, but now that I've chopped the 7 bits, I chopped something into 7 bits and I chopped all of them into 10 bits, I therefore must have chopped the 3 bits I've taken into 10 as well to make it equivalent. What you do to the bottom, you do to the top. 10 times 3 is 30. Let's just do another quick look. What operations do we use when converting a fraction to its equivalent fractions? We use multiply, or if we want to bring a large fraction to a smaller fraction, we divide. Let's look at that. Let's look at something like 8 out of 12. I want to reduce that to an equivalent fraction with smaller numbers. Okay, what can I divide into both of those numbers? I can divide 2, so we'll do that. Okay, if I divide the top by 2, I must divide the bottom by 2. 2 and 8 goes 4, 2 and 12 goes 6. Right, I'm using the divide to make the fraction smaller in numbers, but not smaller in size. Okay, I want to continue with that. What can I divide into both of those? 2. I can divide 2 into that. And we end up with 2 thirds. 8 twelfths is exactly the same amount as 2 thirds. It's just the numbers have changed. But to make them equivalent fractions, if you're changing the numbers, remember, and you're dividing the top by 2, you must divide the bottom by 2. Now, if I hear any of you forgetting that golden rule, I'll know about it. Right, good, got that tucked away. Procedures and knowledge required. Yep, procedures and knowledge, we've talked about those. Remember the rule, and away you go. All right, that's enough about equivalent fractions for me. I hope you've learned something. If you still have problems with that, please let me know. There are so many things that I can talk about in relation to equivalent fractions that I haven't touched on. Please let me know any gaps in your knowledge that you wish to know about. Get in touch with us. Okay, this is Mark. See you later. Hope to see you later. And I'll present some more of these videos for you. Hope they help. Thank you very much. Bye-bye.